Hi, Environmental Science. I'm going to go ahead and record the lecture, for at least part of the lecture for this, so that we can spend more time in class working on other things. So we went through the first few slides of this air pollution presentation earlier, so I'm just going to skip through them if I can. Oh my god, what's happened? Okay, so we talked about this. It's a result of combustion. We talked about the combustion reaction, and these are three of the most common impurities that are left behind after burning coal. So where we stopped is right here at the Clean Air Act. Let me move my picture. So in 1970, the EPA was created in the United States. That was a big environmental kind of success story as far as keeping our air and water and things healthy. So the first major task of the agency was to enforce the Clean Air Act. And here's Richard Nixon, and I'm not sure who those two are, but he's signing into law the Clean Air Act. So this law was a result of the public outcry after a series of air pollution disasters, one of which we're reading about in class right now, about Denora. So that we'll talk about a couple others in this presentation. So also the worksheet about Denora asked about inversion layers and what happens. So this is kind of an example of a thermal inversion over New York City. You can see that layer of kind of smog and fog that's trapped there. And then, so the thermal inversion, right, a pocket of cooler air would be trapped down here along with the pollutants, and the warmer air would be holding it in above, and that air doesn't mix. Usually, warm air would rise, and things would mix around, but there was probably, a lot of times there's not wind, there's a valley, things like that might hold that in. Let me move my picture again. Here's a fun little demo that we'll watch really quick. So,
it's a demonstration that teachers and parents can do. It's pretty easy to do. We're just going to use some juice bottles and some different liquids here. It's just water with different colors. Feel the different juice. Okay. So you'll have to blue is cold. It's nice. Oh, can you get colder today? And this is nice. So let's set up some scenarios. One of the scenarios is the warm on the bottom. So the sun heats here, and that hot air from the bottom. So let's do this.
And you guys could do this at home too.
Good. Now we get this beautiful color mix. So you can see the mixing that's there. The warm, just like the air going in, the cold goes down. So this is a pretty good reason for daylight savings in terms of what's driving. You want to drive when you're swinging the bottom up. Right. Because you want the earth kind of warming, you want the gases moving back and forth.
Exactly. I'm hoping you guys can hear what he's saying.
All right, so here we go. Here's the warm now. It's going to sit on the top. Right. And this is how we start to get that temperature inversion. Okay. Right, so in this case, it's on top there like this. Upside down. All right, here we go. Now we pull it right. And watch what happens. We get next no comments at all. So you can see the differences there. It's not very fun.
So when we have that inversion, all of that air kind of stays in the cold air.
Exactly right.
The warm air.
So that warm air literally traps it down below. And so when the wind of the pollution is there, you see that layer that's right there in the middle. So what a great way to be able to see that concept of temperature inversion. Teachers also talk about convection.
All right, so hopefully you could hear the sound. I'll have to check that later. But that's a good demonstration that you guys can do at home as well. We're probably not going to do it this year just because our classrooms are full and we're supposed to stay, far apart. But you can really kind of see that inversion, how that works using water. So again, here's another diagram of it. So the cooler air, in normal pattern, the cooler air is higher up. As you rise, the temperature decreases, and we learned that during the weather unit. But in a temperature inversion, there's a warm air layer, and see this is kind of a valley here. So that keeps that pollution here and things kind of trapped in. So here's Denora, and this is that kind of book excerpt that we've been reading in class. So that company town near Pittsburgh, they had 2 metal processing plants. It was a zinc work and a steel and wire plant. And we were reading kind of a personal account of someone that was a kid growing up there during that time. And during the time, they didn't realize how bad it was. Remember, until they read in school about this toxic town. So in the days before Halloween in 1948, there was a 5-day temperature inversion, and that's what kind of trapped all this pollutant in that town. So, and the plants continued operating through most of the inversion, and 20 people ended up dying and thousands got sick. They didn't realize back then that it was a problem. So, yeah, they just kept going on business as usual, right? It sounds like the people knew there was some concerns, though, because I remember the mom was talking about how they had to like wipe down their walls, and they had, you know, covers over all of their furniture, not only to protect it from just regular dirt, but the dust and things like that. That the air pollution had a lot of particulates in it that would settle on the curtains, and they said, you know, people didn't really hang their clothes out so much, and they had to they didn't have curtains, they had blinds that you could wipe down because things got really dirty really quickly. Okay, in 1952, there was a similar event that happened in London, except for people in London, they burned coal, and that is low-grade coal that had a lot of sulfur. So that temperature inversion built up, and then the emissions from the chimneys built up in the air. So now, too, like I grew up in the Bay Area, and they pretty much have like no burn days all during the winter. You're not really allowed to have, you know, wood fires in your chimneys, you know, fireplaces anymore down there either, because there's so many people and it's in a valley, so the pollution can really build up. So in London, 4,000 people died during that smog, with thousands more becoming ill from respiratory tract infections. And this was in 1952. Oops. So that resulted in, well, I mean, other things happened in our country as well, but in 1970, we finally realized and acted on the problem. So that required the EPA to set and enforce limits for 6 what we call criteria pollutants. Those are the ones that can be most damaging to human and the environment. So that's sulfur dioxide, carbon monoxide, particulates, ozone, nitrogen oxides, and lead. And we'll talk more about some of these. In our area, we get a lot of the particulates certain times of year, which we'll talk about in a second. So SO2 is a colorless gas, and that's what you smell, the rotten egg smell, sulfur dioxide. And it's a primary pollutant. That's the definition of a primary pollutant, is it's released directly into the air. Main source is coal burning power plants. We do have some in California you'll look at next week. Sulfur dioxide is a secondary pollutant because this results because of chemical reactions in the atmosphere. So sulfur dioxide can react with water vapor to produce sulfuric acid. So it not only it's a primary pollutant, but then when it reacts with other things like water to form sulfuric acid, that can be considered a secondary pollutant. Does that make sense, hopefully? And then nitrogen oxide, so that's NOx. That means that there can be a varying number of subscripts here. That has a reddish-brown color and a sharp, sweet odor. The largest source of NO pollution is synthetic nitrogen in fertilizer in agriculture. So we may see some of that up here. And then also released as part of automobile exhaust. And then smog. Here's a picture of in Shanghai on a high pollution day and then on a clear day. So smog is a mixture of reactants that form, it's a reaction between nitrogen oxide and sunlight. So all of those combined, there's a chemical reaction that happens in the air, and that smog is formed. And LA used to be famous for its smog. They've really done a lot of work. California's done a lot of work to clean that up, but we still do get quite a bit of smog down there. If you've been to LA, you might see that. All right. CO, carbon monoxide, we get that mostly from vehicle exhaust. And this is what, if you start your vehicle in a garage without any ventilation, it can kill you. It's the most dangerous of the criteria air pollutants because it directly affects our body, the red blood cells' ability to transport oxygen. So, yeah, you hear every so often people passing away because they either started their car in the garage or burning those heaters, having the heaters, the portable heaters inside when it's really cold, that will release carbon monoxide too. Like the heaters that you have to light, or gas stoves, like cooking stoves, you can have a carbon monoxide buildup, and those could be deadly, and you can't smell it, you can't see it, it just kind of sneaks up on you. So be really careful. That's something that you could encounter in your life, and I hope be smart about it. Always open a window, always have ventilation. Particulates, small, these are really small. We see these from our wildfires in our area. So these are less, there's two sizes, or less than 2.5 microns, which are really, really tiny. We call those PM 2.5, and then particles up to 10 microns in diameter, we call those PM 10. So during wildfire season, we monitor for those. There's actually a monitoring station at the elementary school. And when the particulate matter is really high, that's when you'd want to stay inside. You want to use a mask like these N95 or any other kind of mask that would filter that out. Because especially the PM 2.5, it can go really, really deep into your lungs and cause a lot of health problems. It can cause inflammation and all kinds of other reactions in your body as well. So these can cause big, big problems. You can't filter them out by just putting even a cloth mask that we're wearing for coronavirus. Doesn't quite help. They're so small that they can get way down in there. So that's the problem that we see with this. And in our area, this does really affect us, especially in wildfire season. Okay, and I'm just going to talk about a couple more in this session. So lead is a heavy metal element. We've talked about lead before. We looked at lead and childhood brain damage too. You guys did some work on that. These small particles of lead attach themselves to particulates, and then those can be inhaled. So the primary source was automobile exhaust when we used to use leaded gasoline. I used to have a 1959 Ford Fairlane that I had to add lead to, and because we only had unleaded when I was in high school, they phased out the leaded gas. So you may still see lead paint on older things as well. So just be careful. We talked about kids eating it, inhaling it or whatever too. Another pollutant is a ground level ozone. We've talked about ozone before. Having it on, down lower on the ground is not good. I'm trying to move my picture so you can see that little. So in the cities, especially, you'll see ozone action days. You're going to look a little bit in the state of the air worksheet at kind of some ozone standards around the state, but it's produced kind of at ground level as a result of nitrogen oxide and volatile organic compounds, or VOCs, that react to sunlight in the atmosphere. And VOCs are released by the evaporation of fuels, solvents, and paints. So even cleaning products have VOCs as well, and they're not good for you either. So ozone action days are alerts issued when conditions are right for accumulation of the pollutant, and you'll see these in the cities in the summer usually. Okay. So the passage of the Clean Air Act in 1970 had really measurable impacts on air quality and human health. So in here in 1970, you can kind of see the sulfur emissions dropping. And oops, you can't really see the carbon. Sorry, the cooled ozone.